13 wants to know why the forces are usually equal and opposite. They don't have to be equal and opposite always, but they're usually equal and opposite. And those forces are gravity and normal force. So take a minute, talk to your partner. Why do you think those forces are usually equal and opposite? Just as a reminder, first law is inertia. Second law is the acceleration one, which is F net equals ma. And the third law is the every action has an equal and opposite reaction. So, talk to your partner real quick. Decide, why do you think those two forces, why are normal and gravity usually equal to each other? Glad you picked this one. I'm really glad we're doing this one because this is an easy misconception. Not an easy question, easy misconception. So here's why it is not the third law. Because you're saying to yourself, Mr. B, you asked me, why are they equal and opposite? And the third law says, they're equal and opposite. Here's why they're not. The equal and opposite reaction law only applies to the same force on different objects. Notice that when we do force of gravity and normal force, they are on the same object. They are not on different ones. They are on the same object, which means they are two different forces. One is gravity pulling down on me. The other is the normal force pushing up on me. The reaction force sounds like this. I hit the wall hits me. I kick the ball kicks me. I push down on the chair pushes up on me. That's equal and opposite. A does to B and B does to A. That's how equal and opposite works for the third law. That is not what this one is. This is A acts on the object and B acts on the object. They're two separate forces. They're not one force acting on each object. Okay? So that's why it's not the third law. So why is it actually the second law? Because F net equals ma. And the net force is 0. If the net force is 0, the forces have to balance. That's why they're usually equal and opposite. They're usually an equal opposite because the net force is 0. Okay? Now, when would they not be equal and opposite? They would not be equal and opposite when the net force is not 0, like accelerating up or accelerating down. Okay? Here's another good way to remember this one. It says usually equal and opposite. Newton's third law is always equal and opposite. They can't ever be usually. They have to be all the time, every time. This is physics. It's not English. There's no exceptions to the rule. Okay? It has to obey that way every time. All right. Great. Let's go. Mason and Hayden, what do you want to look at? 18.